Okay, so good afternoon, everyone. I'm László Gönczy, and my talk would be about business process support for consortial blockchains. And as this session was intended to be a business session, let's just first see how many of you have ever created, at least in a modeling tool, just as a drawing, a business process. Okay, and how many of you have ever written a smart contract code? Wow, still the ratio is quite high. So basically, what we will see now is why it might be important and interesting to port business processes over blockchains. What do we mean by business process support for blockchains? And how this can be supported with open source technologies. So first, we would very briefly talk about business processes, and then see what we can mean by business processes over blockchain. Why should we model a system at all, and what are the advantages of doing that? And then I will briefly discuss how business processes can be translated to Hyperledger Fabric and Hyperledger Composer, as we have some pilot applications which we are creating directly Fabric and Composer code out of business processes. So first, processes are really everywhere. If you look at the figure, these are not typical business processes in a way that these are related to all over the life cycle of software and systems engineering. So there are a lot of these which involve a lot of human decisions, discussions, documents, and cannot really be automated at all. But there are some others which might be automated, and there are a lot of these which might be important to be traceable and to have a common understanding of what was happening during the execution of those processes. I will just briefly show an example about that. And there are a lot of use cases when business processes in general are being used. So first of all, of course, finance and insurance, utility management, in order to give an example which is close to the blockchain world, if you consider smart grids. Transportations and logistics. I think all of you have heard about different aspects of supply chain management or supply chain financing. Of course, if you're talking about healthcare and data management and exchange in healthcare, these are all heavily influenced by processes. What do we mean by processes here is that there is a given sequence of actions which should be performed. There are constraints on who can perform what, and there are requirements on what should be the results of these individual steps and how these influence each other. And there is also an interesting point, which is certification. Certification here does not necessarily mean certification as in the case of education, but certification of systems. And all of these domains are really heavily influenced by standards. Just to give an example on business processes, let's have a look at a business process about incident management. Let's assume that this is a three-level usual support system when there is a distributed organization which is supporting a system or software, and they want to handle incident reports coming from the users. Just to concentrate on one particular aspect of this process, what you see here is there are, of course, some steps. These steps are assigned to certain participants, if you like, certain organizations. For instance, this is the level 2 support, which has to decide whether something should be corrected by the developer or not. And there is, of course, some sort of business logic which is encoded. There are objects representing decisions. There are objects representing sort of synchronization. There is a control logic. There are messages exchanged among different participants. In this case, for instance, level 2 support and level 3 support, or level 2 support and level 1 support. And then, if we consider that, why is it interesting? So why it is really a collaboration of multiple parties? There are a lot of escalation on delegation patterns in these collaborations. So how we decide what to do with one particular item, whether it's the same report or it's a report caused by the same bug as it was reported yesterday, and so on. The team executing this overall, let's say, business process, if you like, maybe or most frequently is distributed even geographically, not speaking about the organizations. But there are some responsibilities and decisions. So we should be able to track why a certain piece of software was corrected or was not corrected. So what do we do? How we take a business process over blockchain? What do we mean if you say that a business process is on blockchain? So first, let's take just this part of a process, which is about we receive an alert and we have to evaluate whether it's critical or not, and if it's critical, it should be logged. And then other things might happen, but let's concentrate on these very small fragment. So step 0, there is no blockchain in the story. So this is a process executed somehow, alerts are reported, evaluated, and if necessary, they are logged. Okay, but then we can realize that, okay, but logs are very important. We don't necessarily trust one participant in the system, if you like, that it should store all the logs. Okay, let's replicate the logs as entries. So step 1, blockchain will act as a data store in a process. This is when the result of logging as a data item is sent to a blockchain and stored in a ledger. Here, the blockchain is simply a data store. It does not execute any sort of business logic other than receiving and storing the log. It might be simplistic, but if you may remember 2 or 3 years ago when some of the business process vendors came out with solutions that, yes, we ported our solutions, we can handle blockchain, this was the typical case. So what they did, they, let's say, created a connector so that an arbitrary step in a process could be executed as a sort of blockchain-based storage step. This might be very important and helpful, not speaking about the integration which is then implemented by this particular step and is not incorporated in the business logic, but still here only the log is stored in a blockchain. Okay, then we can realize that there is an evaluation of the log before, so of the alert before. And we have to decide whether it's a critical alert or not. There can be a lot of aspects influencing that, the timing, the number of similar alerts, the source of event, the content of the alert, and a lot of things. Okay, let's do this evaluation in a replicated way so that no single party is responsible for deciding whether an event is critical or not, so it should be logged or not. Okay, then we can put this evaluation logic over blockchain. In this case, there might be a simple logic, a smart contract, which is evaluating the alert, or which is another option, and it's also implemented by some of the vendors. There can be an evaluation logic which is not in a blockchain, but attached to all nodes which are participating in a blockchain. All nodes are executing their own logic, and then they agree on the result of the execution. So it might happen that the execution is not over blockchain, but it's distributed, and the result is, let's say, based on a sort of consensus and logged on the blockchain. But still, in this case, not the process is logged on the blockchain, but there are some typical steps which might be sort of replicated over blockchain. So let's execute the entire thing on blockchain. In this case, there would be a chain where the nodes executing the smart contracts will execute the logic of the business process. So the business process itself would be executed on chain. What are the consequences of that? Of course, for the positive consequences, I think everyone can say that it would be replicated, cannot be tampered, and things like that. Of course, about the negative implications or the challenges, one of the challenges might be how to handle user input and how to synchronize all necessary data which is necessary for the business process execution so that it would be available from all nodes executing the smart contract. So the motivation to create such systems was use these sort of high-level definition of collaborations, like, for instance, it was in the case of incident management. Concentrate on the situations then when there are different participants. And in the case of classical business processes, these are executed in a centralized way. So if we collaborate, we are together doing, let's say, an incident management software, then one of the partners will host the software, execute the things. But still, there will be a central entity executing all the steps. Whereas in the case of consortial blockchain platforms, we can talk about transactions which are executed according to smart contract definition, again, between or among different participants, but here executed in a decentralized way. Okay, for how to achieve that, how to translate a business process to a smart contract, one of the possible solutions is to use sort of classical model-driven methods, when a lot of the coding is substituted by executing transformations, which takes sort of high-level inputs, like in this case, business process definitions, and create, in the design phase, in an automated way, a lot of assets. In this case, data definition, smart contracts, and more. We'll talk about a bit later in more details. What is the advantage of doing that like this? First, a lot of things can be validated right at the model level. Models can be evaluated. So if we want to see whether there can be a specific case when an incident is, let's say, classified as important and will never be classified as it should be repaired, so whether this can happen in our system, then we can perform this, we can do this right on the model level without creating code, not speaking about creating blockchain configurations. And of course, not only during the design phase, but also when we are running the system, we can create some sort of test cases from the models with which we can verify that really the smart contract, if you like, is performing in a way which we intended to. And of course, another motivation to do this in a model-driven way is that in a lot of cases, that also it was mentioned by some of the speakers, when we are creating an application, a blockchain application, even if you take the supply chain use cases, then these are not greenfield projects. So there are a lot of things already existing, should be incorporated, should be somehow attached together, should be able to communicate. And for that, it's important to see the whole picture, for which a model can be a good way. So instead of coding the contract, what we can do is to do some sort of data modeling, then create processes where certain policies can be checked right on the process. So without coding, we can check whether the process will follow our policies. We can explicitly attach stakeholders to different sort of operations. So instead of having code and reusing the code, we can reuse it at the process level. So when we are creating something which is translating a process to a certain code, then still we have multiple possibilities. One possibility would be to create a general purpose engine, if you like, which gets a process as an input and works according to the process definition. If you consider Composer, it's a bit like similar. So it's hiding a lot of details from the user. It receives a business network archive as an input and works according to that on top of blockchain. Okay, why is this a hard task to perform? One has to create an engine which is correct in all cases, and all sort of correctness issues must be ensured at the engine level. So if I create an engine which is top of blockchain, I have to be able to prove that in all possible cases, for all possible process definitions, it will work as it should. Another possibility is to take a business process and for all given business processes, create a smart contract. So at the end, create something which is at the level, at the abstraction level of the blockchain. In this case, there is no engine acting like a process engine, but there will be smart contracts. Why is it, in some cases at least, a bit easier to achieve? Because in this case, the concepts from the process can be directly traced to the concepts of the smart contract. So there is no intermediate level. And it's easier to verify the correctness of the smart contract produced and to verify whether it behaves as it should according to the process definition. And for this implementation, a lot of boilerplate code can be generated. So a lot of error-prone things can be eliminated from the process. And of course, there are some things which will be still to be implemented manually, which are the business logic of the individual steps if they are, let's say, more difficult than modifying the data. So if instead inside a step there is a business logic, then still it has to be attached somehow. In this case, for instance, as a function in a smart contract. So I mentioned that there can be processes where it's really critical to see who performed what. And this figure is a schematic figure about critical system verification. We had a project together with some of the companies which are performing so-called independent systems verifications for major companies. And what is their challenge? The challenge is that they have to prove that a critical system, for instance, a satellite, was developed according to the best requirements and according to the standards, and according to the checks they performed and according to the checks the original developer performed, it should work, and it should be, let's say, verifiable why someone stated that a certain part of the system will work. Okay, what are the challenges here? So these projects, are very long projects. So a 2 or 3 year project is a very short term. Typical term is 5 to 6 years or even more. During these, documents will change, teams will change, organizations will change, and still, one has to guarantee that these things would be flying, and also, if something is wrong, we have to be able to trace it back. And although it should be, let's say, obvious that this is executed, all of these steps are executed according to processes, in reality, these are executed very much in a manual way. So via emails, like using PDF documents and things like that. So although there are a lot of energy put into the individual steps of checking these critical artifacts, a code, a design document, or even a test case, or a result of a test case, if someone will ask 5 years after why the decision was made, it would be absolutely non-trivial to answer. So why model this system? What do we gain with modeling? So to support modeling and model-based development, there are a bunch of software technologies which are used in several domains and can be used in this case as well. So most of you have come here by an aeroplane, or by car, or by train. And all of you who use these vehicles were using software which is generated from models. So there are the technologies available to do this and to do sort of transformations which changed models and change the model to another sort of model, and then to generate code from the model. And of course, in these domains, it's compulsory to do things following this approach for the specific reason that a lot of errors can be checked right on the model level, which with testing will not be easy or at least possible to find. And then, of course, a motivation is that we can test at the model level before any deployment. And also, if we have a model, we can generate so-called self-checking code fragments, which are available during operational time. So I mentioned that there might be steps in a business process which are still implemented sort of manually and attached to a smart contract, let's say as a function invocation. If I'm not able, or if I don't trust that the function will always perform correct operation, then I can still add some sort of self-checking mechanism which will check whether certain requirements are met by the execution. And these checking will also be done in a distributed way. So from basic correctness issues, like if I add someone to something, then the balance will be as required, to domain standard requirements, a lot of things can be checked by these generated code fragments. Okay, and another thing for why is it important to model these systems? There were a lot of discussions about blockchain scalability, about Emerald, Caliper, eBPF, PSVG, and a lot of other acronyms, if you like. But is it really true that in all cases, this would be the most important point? And of course, not necessarily if you consider these processes. So if you want to find the bottlenecks, then let's see what are the system components. So if, for instance, in the case of the supply chain management, which are the systems which are all cooperating in order to create something which is partially executed on blockchain? So there can be a lot of supporting systems, and it's absolutely not true in all cases, or it's a question which should be evaluated before, of course, deciding technological issues. What are the requirements for a particular thing in the process? In this case, is it true that blockchain would be the black sheep in the system from a performance point of view? Or might be that all of these TPS issues are not important in a specific field because there won't be that high workload requirements for the specific blockchain-based functionality of the system. Okay, so let's see what are the main elements of a business process. There are the participants, the tasks, there is the data, and there is a sort of control flow. And of course, there are a lot more elements according to the standards, but these are, let's say, the most important parts. So how this can be translated to sort of blockchain platforms? So if we take participants, then of course, it can be defined a different level of abstraction, but most probably a participant, which is a sort of role, can be translated to an organization or a role in an organization in the network. A task in the process will be translated to one particular transaction, which will be executed, and data, which is handled by the process, so this is the data which is explicitly handled by the process variables, if you like, would be translated to a data model handled by the smart contract. And there is the interesting thing, the control flow. So how to guarantee that the smart contract, which will contain a lot of transactions corresponding to the tasks in the original process, will act as it should be according to the process definition. This can be achieved by multiple ways, but one possibility is to create constraints which explicitly constrain on what transaction can be performed at a given state of the process. So transactions are enabled just at the right moment, just at the right logical state of the process, when they can be executed. So first, let's see what to do with Fabric. We created a bunch of transformations, and I won't go into details of that because it's quite technical, about how to achieve that something at the end, which is code, is performing according to the model. And basically, what we did was two sort of chains of transformations. One was to create the skeleton of the smart contract with the participant information, the data information, and the transaction information in general. And then to create something which is maintaining a state model over all of these possible steps. And this thing here is, let's say, knowing about all possible allowed executions in the business process. So in all logical states of the smart contract, it would be able to decide whether a certain transition can be executed or not. So there would be a constraint model generated, which is constraining on which transaction might be alive and which not. And of course, to do this, we need to introduce a sort of model which is maintaining information about whether a certain task is started, might be started, or is just ended, and what can be the next steps in the process. So from the initial state, we will, at the end, get to the final state of the process, and there are some routes which might be followed during the process execution. And to support this, we created something which is a sort of platform-independent model, because if you look at the model, there is nothing really specific about Hyperledger here. Of course, the main concepts like operation, constraint are here, but the model itself is more, let's say, concerned about how to model the access constraints and how to attach states, operations, and participants together. So these here will be translated to fragments of smart contracts, and then the authorization will be performed at the smart contract level. Of course, still, to authorize the individual user in a specific organization is left to the organization. So whether someone is really what he's claiming to be in his specific organization is outside of the system, the task of the system is decide whether that particular entity might execute a step on chain or in the process. Then if we look on how to do this on Composer, and to be a bit optimistic about Composer, but Brian Beildorf told us yesterday morning, he told something like Composer might get reshaped or might get re-implemented or something. So let's follow this optimistic way about Composer, because we like Composer pretty much, because I think it's a very good and effective tool to create applications. So what you see here are exactly similar things as they were in the process. So assets, transactions, access control rules, which are here elements of the language, and query definitions. From these, of course, these would be the most important in order to create something, a business network archive, which will act as it should act according to the process definition. Again, let's take the process elements and then turn them to concepts of Composer. So again, the process will be composed of different pools, if we follow the BPM standard. The simplistic way is to attach to each pool one specific participant, which is one specific role. Processes will be assets. So if you're familiar with Composers, there are assets, there are transactions on these assets. So processes will be, again, assets with their own possible states, which will be captured by state variables. So I will say that, OK, there is this incident management process as an asset, and this asset is in an initial state. And then these assets would be connected to the tasks, which, again, would be assets connected to process assets and connected to a lot of other things, which is implemented by variables and logic, access control logic, which is, again, derived from the control logic of the original application, and of course from the participant information. So these together, the constraints and the ACL logic guarantee that the execution of the process will follow the way it should. So for instance, let's take the supply chain finance example, where there might be a lot of participants collaborating. Let's create a simplified process out of this. So quite a simplistic process could be when there is the supplier, there is the buyer, and there is the financer. And the goal of the process is to ensure that the supplier can get his money quite early, it gets financed by the financer, and the buyer will get the goods. And of course, they have to cooperate, so they have to trust in each other. For that, there should be a platform supporting these operations. And of course, this could be a centralized platform as well. But maybe, especially if we combine multiple financiers, then it's really a collaboration which can be implemented over blockchain. So let's say, how can we create an application to support this process? Then there would be the Composer as a central entity with all this stuff. There is a front end for that. And then we can create something which is like that. It's like a simple task environment. It's a very simplistic one. When there are tasks which are instances from a process generated from this model here, and then each participant will see the task which it's allowed to perform or might perform. And then in the big background of this, there is a Composer business network archive, which is generated from this particular definition and follows these constraints. So what are the constraints? There are the constraints which are about the sequence. There are the constraints that, for instance, these things might be executed in parallel, whereas here we should make a decision. So we should be able to decide where to go at this particular phase. And also, there is data dependency between different actors of the process. For instance, here, this data should be provided there in order that, in this case, the supplier can evaluate the financial proposal and then either accept it or request another one. And all of these things are translated to transactions, assets, and constraints over Composer and might be executed there. Okay, what is the benefit of doing something like that? Is that instead of arguing or discussing about the smart contract code and whether the specific smart contract code is following the requirements of this domain or the requirements of the individual participants, we can do this right at this level. So if someone argues that, for instance, I want to include additional business logic somewhere here, then it might be included right here, and then the generated code, the generated archive in this case, generated Composer application, will follow this particular logic. So what might be the conclusions of using such solutions, which are, of course, not unique in a way that a lot of players are now developing things to support business processes over blockchain, like IBM, Monax, Microsoft, and a lot of others. So, of course, not all business processes should be transported or translated over blockchain. The ones which really are expressing collaborations, when really there are multiple parties which together we should achieve something together, or which contain a critical step, for instance, in the case of critical system certification, where a step should be verifiable after years by different parties, by authorities or regulators, then these might be ported over blockchain, and this can be done in an automated way if we consider the data model, the business logic, and the access layer. Of course, a lot of additional things must be performed in order to have a working application. So all the cryptographic things or the key access and all of the things which are at the configuration level of the blockchain should be done still. This might be also supported at a given certain by model-driven methods. Also, another possibility is to generate code not only from processes, so from process logic, but also from state chart-based logic or state-based logic. And once we have these models, and I was telling about it's good to have models because then a lot of things can be evaluated at the model level without testing of running applications. Then, of course, another interesting thing is how to verify these models, how to find, let's say, bugs in a model, which, of course, will cause smart contracts not to function correctly. So also, I might mention that some of this work was created last year in a Linux Foundation internship with one of our colleagues in a project called Contract-Based Business Process Execution, where the purpose was to generate Fabric code directly from the business process definition. And then what you see here, this transformation chain was implemented using all of these technologies are open technologies, but still they are quite mature because a lot of these technologies are used, for instance, in the automotive industry as well. So when I was telling that if you were coming here by a vehicle, then you were most probably using some software which is generated automatically, then we can also add that it's very probable that you were also using a software which is created or partially created by some of these technologies, because these are used in airplanes as well, for instance. So basically, that was what I'd like to say about business process support in blockchain. And I think I have 5 minutes, if I'm correct. So I'm open for questions. Thank you. We have a prototype. The question was, is there a tool available to create a business process or a smart contract from the business process?
Which eventually will become a smart contract.
OK. For this, what I was showing, the Fabric thing, is in a phase that it would be published soon as a sort of open project. For the Composer one, let's talk about the token, then we can show how it works. But it's a proprietary one, that particular thing. For the business process modeling, there are a lot of free tools. So soon there would be available one which supports the business from the model to the code generation to Fabric. But still, we have to improve it a bit because it was created to a previous version of Fabric. So now some of the codes should be tailored for the current version.